So in the previous session we have understood the gearing diagram, but the problem still remains that we still have to find out the speed at the third shaft of the feed box in order to be able to draw the speed chart or the feed chart. This is understood by this formula N3 times I times pi mz is equal to S. Here I is the transmission ratio of the worm and the worm gear pair, and it is assumed to be 1/50. M is the module of the pinion of the rack and the pinion. Z is the number of teeth of the pinion, and S is the feed per revolution, that is the displacement of the rack per revolution of the spindle. So you must have noted that we have drawn the structural diagram considering the feed, and from the feed we need to back calculate what is the RPM at the third shaft of the feed box. To understand this formula, please see this diagram which I have drawn. This depicts the pitch circle diameter of the pinion, and it is meshing with the rack. The diameter of any gear is equal to module times the number of teeth, so the diameter is mz. And if we want to calculate the circumference is pi times d. Combining the previous formula, the circumference becomes equal to pi times m times z. So what is the significance of this? It basically means that if the pinion rotates one complete circle, then the rack would move the distance equal to pi mz. But the movement and the rotation of the pinion is governed by the worm and the worm wheel, and its transmission ratio is given by I, and it is multiplied by N3. So basically N3 times I times pi mz gives you the feed. So if one can calculate the feed, then if the pi, m, z and I values are known, then the N3 or the RPM or the rotations at the shaft 3 of your feed box can be calculated. Now for the given values of feed and a phi value of 1.41, the values of feed in geometric progression are given as follows: the 0.1, 0.141 up to 1.11. When we go ahead and assume these values, that is I is 1/50, module is 4, Z is 12, and when we put it in the formula, we get N3 as 0.33 times S. Please note that the RPM at the third shaft of the feed box will always be proportional to feed because they are simply the constants which are giving the constant of proportionality. So based on this, one can now calculate the n values. The values of n are 0.33 S1 to 0.33 times S8, and all of these values are tabulated as shown in this slide. Once we get these values, one can go ahead and plot the speed chart as usual. So here you can see the structural formula is 2142, and the same process as discussed earlier has been used, and the feed chart has been plotted. So the origin of the feed chart is kept to 0.203. You may as well arrive at some other number, but based on this number, your original transmission gearing ratios should be designed such that you receive this original starting point. Thank you.